Hey everyone, it's Liam Mulcahy here with the SAT initiative. We're looking at G14, similar geometric objects. This is the last SOL. Whew. Alright, now what we got to do is we basically are looking at, it kind of builds off of what G13 was all about. We're looking at comparing ratios of lengths, perimeters, areas, and then we're determining how change in one dimension affects the changes in other dimensions, or rather in other aspects like area and volume. And now determining how changes in area and volume affect those other dimensions is another kind of key concept. But the best thing we can do here is do some problems. So create a few. So compare the ratio of two heights of similar cones. So the ratio of two heights of similar cones is 1 to 3. What is the ratio of the volumes? And what you basically do is you just plug in 1 and plug in 3, and you can see that that just returns 1/3, because that makes sense because the height here, it doesn't have any power. Now, if it had been h squared, completely different story. It might be 1/9 rather, but because height, it's just height and not height squared or height to the third, it's just 1/3. Okay. And now comparing ratios, the second example. So basically, this shows you how circumference, area, and volume of circles. This is a circle. This is also a circle, and this is a sphere. You can see how they all change based on the different ratios in radii. Now, changing one dimension. So if the radius of a circle increases from 3 to 9, how much does that affect the area? So basically, it affects it by 9 because we know pi r squared is the formula for the area of a circle. Now, if we double the radius of a cylinder, what happens to the volume? We can see that we just multiply by 1, and then you do another one by 2. You could do 1 and 2, or 2 and 4, or 3 and 6, as long as the ratio is 2, or doubling. So we see that results in 4 times increase. And now one square base pyramid has twice that of the other. We can see that it's asking if the height of two pyramids are the same, what is the ratio of the size of the base of each pyramid? So this is a little tricky because we do 1/3 times the base times the height, and we multiply. We want it to result in 2, so we multiply. So we basically are solving for we want b to double, and because we know that the base is square, that both sides are going to be equal, so we get s squared, and we take the square root of both sides, and we realize that the ratio between those two sides is 1 to the square root of 2. Or you could also, I'm not sure how you could do it, but anyway, 1 to the square root of 2 is the ratio between the two sides of the two different pyramids. And now this is another one. This is an SOL problem with similar objects. Basically, what you want to do is model divided by actual equals base is equals. Basically you do model divided by actual for both, and you know that they have to be equivalent. So basically all we have to do here is just solve for base of the model, and we multiply by 55, some simple algebra, and we get 50 millimeters. So anyway, that's pretty much it for this objective. The key is going to be doing some practice, but that's just a basic overview of this objective. Thanks for tuning in.